All right, welcome to the Power Driven Podcast. We're back with a fun episode today, something that's going to way over my head. I don't know much about it, but I'd like to have Will and Myer here who are very good at this stuff. We're talking about the 4748 Dodge 4-speed transmissions, all the problems, all the things you need to know, what you need to do for certain power levels. We did an episode on the 68 a little while ago, and that seems pretty popular. So we thought maybe we'll see if some guys need to know some information on the 48 and 47.
You've wondered, why is the 48 RE the most unreliable diesel transmission on the market? And then why can it be built to be the most reliable racing transmission on the market? Why? This doesn't make sense.
Is it more unreliable than the 68?
Dude, that is a hard one. I don't know. A lot of people hate the 68s, but I would say 68s break from power. 48s just break whenever they want. That's just kind of the way of the road.
So if you have a towing truck and you're trying to make your 48 or 47, so if you have a 12 valve, you have a 47 RH if it's an early like 94, 95, or a 47 RE if it's a 96 to 98, or if you have a VP 47 RE, and in 2003 they went to the awesome 48 RE, but they're all basically the same dang thing.
Yeah. The main differences is as they got newer, they got a little bit better planets, added some extra clutches, and then they changed the sensors and stuff on the side of the transmission. That's ultimately the differences there.
Not much.
Not much.
There's a few other things we'll talk about in a minute. But, but really, like, when guys get these trucks, we're talking 94 through 03 or 02. This is what we're talking about. So, these trucks, a lot of guys are wanting like a nice tow rig, 500 horsepower, tows a trailer, fun to drive around town. What do these guys need to know? Like, what are the issues that they're going to come across, and how do they fix them?
I mean, at 500 horse, I'm sure Will will have an opinion on this, but 500 horse, you need a decent transmission, not the stock one. But if you're trying to go around and towing, like, say, 300 horse or stock, things you need to know is, first of all, your adjustments. Second gear band adjustment. That's something you should be doing every time you service the transmission. You should be servicing the transmission. At 20, 25,000 miles is where we generally recommend. That's going to do a lot to help that thing out. And if you want to do it, all sorts of favors, giving it like a pan off upgrade kit or like a valve body or something just to really help bump those pressures up. Factory, they run around 100, 110 PSI. You put a valve body into it, now it's making 150 PSI. Every single clutch is going to hold that much harder in that truck, and just helps prevent slipping in the future.
No, wait a minute. Like, when you say service transmission, that's like fluid and filter change?
Fluid and filter change. And that's what sucks about the stupid 47s, especially with the stock pan, is you don't have a drain plug. So you got to pull that whole pan off in order to do it. But yeah, you need to pull the pan off, and you need to drain the fluid, and you need to swap a filter into it.
So if you value your transmission, probably a deep pan is in your future, because you're going to hate dropping that pan.
It's a good thing on so many accounts. Not only is it makes it easier to service, so you don't regret it as much, but also it helps add fluid capacity, which helps coolant temps, and it adds, like, a lot of them have fins and stuff on them to help dissipate even more heat, and that's going to help with those fluid temps as well.
So I remember hearing in like wives' tales, like, you don't want to change your trans fluid, because if it doesn't slip, if you put new fluid in, it's going to start slipping. That's like, yeah, dude, don't change it. If it's working, if you change it, you're going to ruin it. Is that not true, Will? You kind of, I know it's not true.
No, good new fluid is great for the transmission. Doesn't cause problems. In the past, where that wives' tale came from is if you haven't serviced your transmission for 500,000 miles and you put fresh fluid in that has a lot of fresh detergents in there, they will break up all that buildup. All that buildup and sludge is going to get floating around in the oil. It's going to plug the filter. When the filter gets plugged, the line pressure drops and clutches burn up. That's pretty much it. It's not like there's not seals that are going to swell and leak. Well, a lot of times when they swell, they quit leaking. So you're not going to cause leaks from fresh fluid.
Yeah.
But most of our failure analysis comes from tearing down old core transmissions we get. What we come in the door, that's how we can see what the common failures are. A lot of transmissions that come in, it's not like they're worn out from mileage. They have a plugged filter, and they burned up a clutch because it didn't have line pressure. I'd say maintenance is number one failure point we see on these things.
Yeah, so if you have a bad transmission, your transmission is faulty, and you go see a shop, kind of look in the mirror, like, when's the last time I did a fluid and filter change? If it's been a long time, this big bill might 100% be your fault.
Yeah.
Which kind of sucks to admit, but it happens.
The second most common failure that we see will be a broken or ruptured seal. So there's all these hydraulic pistons that apply clutch packs,
Mm-hmm.
and those seals will get old and brittle and they rupture, they rip. What we found is those seals get hard and brittle from heat. So extra heat in your transmission accelerates the wear on those rubber moving parts that have to seal the hydraulic fluid in there. So that's why a lot of guys like to put a deep pan in there. It's a very good preventive maintenance because it holds more fluid, so it's going to run cooler. Plus, the deep pan is aluminum normally, has cooling fins. It runs cooler. That extra capacity lowers the average temperature of the fluid, and lower temperature keeps the seals fresh longer.
Mm-hmm. Yeah, for sure.
So what about failures from just power, though? I mean, where do you...
So before we go over that, I actually wanted to say you did a nice little list of everything there. Another thing I've seen a lot, and this is sad because it's on built transmissions as well as stock, is the cooler lines. Lots of people have blown off cooler lines, rubbed a hole in their cooler lines, towing a trailer, whatever, don't realize that they just puked all their fluid out. And whether it's their 200,000 mile stock unit or it's the brand new built one, they probably just toasted it. So that's also a really good thing to like at least be up on and like watching. Make sure you don't have a rub point or rust or whatever that's going to blow off, or old hoses or whatever it is.
So the factory cooler lines are steel. They rub together. In fact, one time I was towing with my 9812 Alpha to a race in Arizona. I got to the top of the mountain right here behind Cedar City doing the shortcut up over by Duck Creek. And right when I got to the top, right at about 10,000 feet, trans is just scalding hot because I just pulled a big heavy trailer up the mountain. Boom, cooler line, let's go, dumps all my fluid out. And the first sign was overdrive dropped out. I'm driving, I have no idea. And all of a sudden overdrive goes away. It's in third gear. Lockup goes away. Then it goes to second gear. And then pretty soon it won't even move. All in a matter of, a quarter mile as I slow down and pull over. Luckily, I was headed to a race. So I had transmission line, like hose in the truck just in case. And I had fluid. So right there on the side of the road, I fixed the ruptured steel line with a piece of rubber hose and hose clamps, got her back on the road. And you know what? That transmission lasts another 50,000 miles. So if you catch it early, sometimes you get lucky.
So one thing you mentioned earlier, I kind of want to go back to because it's like not obvious what we're talking about. When we talk about fluid and filter change and maintenance, that's pretty obvious. Keep my fluids topped off, change them, change the filter. You said band maintenance. What does that mean? Like from your average guy, like what do I have to do to maintain the band, and what even is the band?
So there's two bands in the transmission. There is the frontmost band. That's the second gear or intermediate band. There's another band inside that's the low reverse band. That's used in manual first gear or in reverse. The low reverse band doesn't get nearly as much wear. It's kind of more guys that plow snow and they're going from manual first to reverse, rocking trucks a lot, backing up a lot. If you back heavy trailers, sometimes that band will kind of stretch and get wear, but the main wear one is the second gear band.
Mm-hmm.
I would say 90% of the 48 RE, so this is the newer, awesome 2003 and newer, the number one failure on those is the second gear band. If somebody has maintained it and take care of everything and they haven't overpowered the transmission, the second gear band wears out and it's down to bare metal. What happens is that band has to grab for second gear. When it goes to third gear, it has to release that band off the drum and start spinning the drum that band is holding stationary for third gear. So there's a change off from applying the band to releasing the drum. That is all controlled with like a little servo, and there's like an external adjuster that what is it on they have a Torx like
T40. Yep.
There's a T40 Torx and a 3/4 lock nut on it. And you're supposed to basically run that in tight, which is where the band is adjusted, and then back it off 1.5 to 1 3/4 turns. Some manuals say 2 turns, but essentially you're trying to get it just close enough that the servo can still apply it, but it doesn't drag.
Mm-hmm.
And so that needs to be adjusted every time you service the transmission. You should do that. If you're dropping the pan and you're changing the filter, you should also check that low reverse band. It gets neglected a lot. I'd say most guys can get away with almost 100,000 miles before adjusting that one. But that second gear band, no.
Yeah, definitely do it every fluid change for sure. And the lower reverse band has a lot of travel, so even if you neglect it, it can generally survive for quite a while. Like us full manual valve body guys adjust it on the loose side just to be able to get like the more desirable trade-off there. The second gear band doesn't have that luxury. Like you start getting it a little bit out of adjustment, now the servo isn't, it's bottoming or whatever else. It's not actually applying the full force against the band. And then once that happens, it's a downhill spiral quick.
Because that drum will spin and slip a little bit in second gear. It heats up the band. It bakes the lining. Gets it all crispy. And then even if you adjust it properly after that, the lining commonly flakes off, or worse, it just doesn't hold and it still continues to slip even if it's adjusted right. And pretty much, I mean, they make slip-in bands that are kind of like an aftermarket Band-Aid, but realistically, that usually means the transmission needs to come out for a rebuild, especially if the drum got all scarred up.
Yeah, for sure.
So like, I know a while ago you designed our pan-off upgrade for these transmissions. What like level of power is that good for? Is that for your 500 horsepower guys? Is that more like what's that good for?
Because you're starting with your factory transmission, you are starting with an unknown. Like if it's a perfectly healthy transmission, it's good to, let's call it 400 to 500 horse. More like 400 horse. Because that factory converter.
And we're talking to the tire horsepower.
To the tire. Yep. Because that's really your weak point there is that factory converter. But all that extra pressure, all those parts in there are really helping get everything to hold to that point. It comes with a valve body, which increases your pressure, like say from your 100, 110 to 150.
So stock line pressure is about 100 and, I mean, it depends on
it depends on
which
the
year.
valve body.
But let's say between 100 and 120 if it's a 48 and it's in lockup and everything, but 100 to 120 maybe. And the pan off
150. Yeah, 150, 155 or so, depending. But yeah, and then it comes with a 4.2 lever, which on the 47 valve bodies or 47 transmissions, that's an upgraded lever. So it
but on the pan off, we don't do that because you can't change the lever without dropping.
Spacing, not lever.
So all we really do, another common problem, when you get the line pressure too high, the band strut will bend. This is just a metal rod that's connected from a lever to the second gear band. And so great, we can put a high pressure valve body, but if it bends the strut that applies the band, you're not gaining anything. So part of the pan off is you get this heavy duty strut that won't bend. And then the other side of the band is the anchor. And the anchor is a little metal wedge piece that goes under that adjusting screw that you adjust from the outside. Sometimes that factory anchor, it's just a kind of a cheap cast part. It'll split from the high pressure. So we give you a good strut and a good billet anchor so that it can handle the high pressure. And then with this high pressure, if you're normally running, let's say a 47 and you have 100 PSI, you have 150, you just got a 50% power increase because all those clutches are hydraulically being pressed 50% harder.
Yeah.
And so with that, you say that's around a 400 horsepower.
Yeah, it depends on how healthy your original transmission is. But if you had a good unit, 400 horse.
If it's already smoked, it's not going to fix it. You need a real transmission, a rebuild. But that's a pretty...
it's not even the clutches that fail at the 400. It's mostly the single disc lockup clutch in the factory torque converter can't handle more than about 800 to 850 foot-pounds of torque. And so we put a horsepower rating, but really it's that torque is too great and it pushes through that lockup clutch. Now, you can push through the lockup clutch and slip. There's still a torque converter there to kind of couple. And if you don't let it slip too long, there's a lot of fluid in there. It doesn't overheat too fast. You can kind of get away with it. There's a lot of guys that say, my stock trans held 800 horsepower. It is, but it's not really holding. The lockup clutch is slipping and the torque converter is doing the work and everything else is, hanging on for dear life. It won't last long there, but realistically, the factory stuff, if it had a better torque converter, I'll bet you could hold dang near 1,000 foot-pounds of torque short term.
Very short term, but yeah.
Which would be very, very high in any gasoline racing transmission application.
That's a darn goddamn race car right there.
Yeah, so I mean,
basically the worst transmission on earth is an awesome gasser racing transmission stock. If you only make 1,000 foot-pounds of torque.
Yeah, it really would. Wouldn't the converter be too heavy, or is that not a thing?
It's a pretty heavy converter.
The gas guys, like
13-inch converter. They're talking like 9, 10-inch converter. This one's factory 13. They're like, boom.
Yeah, really big, really big. You talked about cooler lines and how you had them fail on a trip for your family. I know we do cooler lines because of this. Like, is there any drawback to doing a upgraded cooler lines? Like, what? It's just obviously the flow's better. I know we have some issues like a drain or something, drain back.
So there's in the factory line, it's actually not on all trucks. There is a check valve by the heat exchanger. Dodge did that.
And that's that big submarine tank looking thing that's under the turbo. on the side of the engine block.
Yep. So there's a check valve there, and like I say, it's not on all of them. I think it was optional at some point where it would leave the lot, and if the customer complained about drain back, they'd install that check valve. It didn't really make it any better. It just made it so the customer wouldn't complain, because that ends up being a restriction. And if it's a plastic check ball in there, it can get hot, it can get brittle, and it'll get sucked in or like get deformed and end up plugging off passages. And you plug your cooler circuit, you're going to have issues pretty darn quick. But regardless, especially in racing stuff, we get rid of that check valve because it causes all sorts of problems. But even in like your tow trucks,
the ball itself's metal, but it has a plastic surround shell that, the seating area is plastic's the problem, and that makes a mess.
But either way, it causes a restriction, and if it fails, it causes all sorts of problems. But it is a restriction, and so with our line setup, we get rid of that because that way you get full flow, better flow through the cooler, which means you have more cooler flow, so it runs cooler, but also you get less pressure left in the converter. And that just helps everything with keeping the pressure in the converter lower. And so, that's really the only side effect.
But when you shut the truck off for a couple hours, it'll drain back.
Yep.
And if you jump in the truck in park, it does not feel the torque converter as fast as neutral.
Mm-hmm.
So if you cold start a truck and it's running for 3 seconds and you slam it into drive, it'll just feel like the transmission's slipping because the converter isn't full. And so it's just like it's like spinning out on air because there's no fluid in the converter. It doesn't hurt anything. It's just
and then you put it in drive, and if you try to take off, it feels like it's like almost in neutral, like it's really slipping, and then it kind of slowly like goes into gear. Yeah, it's not slipping any clutches. It's all fine. It's just that converter that's supposed to have fluid coupling is like air and fluid coupling, and that's just the way it is.
That's really noticeable. Like you hop in a truck, you put it in gear. It's kind of a weird feeling. Like, oh, geez, man, did I just roach my trans? Because it doesn't go anywhere. And then it starts to move, and you're like, I
remember my old factory 97 had that, and I started up, and I was like, oh my gosh, I knew these autos were junk.
But the quick fix, if you put it in neutral for about 3 seconds, it fills the converter really fast. So it's not a problem. It's just an annoyance, and so they added a check ball. So if you do an upgraded cooler line kit, you're getting rid of that check ball because we don't want to create a failure.
Yeah.
Yeah, for sure. So let's talk about like some of the differences. We talked about there's a 47RH, 47RE, 48RE. Kind of go through like, maybe like you're doing a swap into an old Chevy or something like that. Like which one you'd recommend? Like what are the differences and pros and cons of these different transmissions?
So that's actually a great question because I get a lot of people that ask me like, oh, I have a 96 and I want to upgrade to a 48RE, like, cause it's better, it's superior. Don't. All the internals, the things that are better about a 48RE, they're all internal to the transmission and they can be swapped over to your 46. So what I tell people, if you're doing a swap, that's
your 46 or 47, you mean, right?
Did I say I meant 96?
You said 46.
Yeah, 47RE 96 truck. What I tell people is if you have a Dodge, like put the case in it that it came with. So if you have a 47RH, put a 47RH in there. You got a 96 to 02, put a 47RE in there. It's got the right neutral safety switch. Everything will plug in. You have an 03 to 07, put a 48RE in there. Again, the neutral safety switch is all going to hook up. It's going to be right. And then if you have like an RH and you're trying to make power, if you really want to go extra, either get a built transmission that comes with all this stuff or just put a 48 internals into your 47. Everything bolts right in. It's not a problem. And it's really nice because it will just bolt in and all your sensors, everything is just still going to hook up.
Now, the swap guys, they commonly hunt the 47RH, which would be a 94 or 95 model. The reason why is it has a hydraulic governor in the tail housing, so no electronics are needed to shift first, second, third gear. You put it in drive, it'll shift first, second, third. You manually shift first, second, third. It'll do that. Then all you need for fourth gear, which is overdrive, is you need to add one 12-volt power wire, the center pin, and then if you want lockup, you ground the rearmost pin. And if you want, lockup, and if you want overdrive, you ground the front pin.
Mm-hmm.
And so basically, you need 3 wires to control the transmission, have all 4 gears. Now, how you ground that, guys make elaborate controllers as simple as a toggle switch. There's manual shifters with little latching buttons. There's all kinds of ways to do that. The reason guys want that is they feel like they want that automatic shifting setup. However, we found that as you're turning up the power in these things, you like to control the shift points better. And I used to race a 95 that had an RH, and I was trying to raise my shift points. And I pulled the tail housing off like 20 times, shaved governor weights, added aluminum weights out of a gasser transmission, just modifying all kinds of stuff, trying to get it to shift where I wanted to, where if I just had a full manual valve body, it would shift when I did the shifter. So some guys, they go that route because they want it automatic. They're like, there's no electronics. It sounds simple to them. But I really think the right answer is if it's any kind of a performance build at all, I'd say 500 horse or higher.
Yeah.
That full manual shifter is so nice. It's easier than a manual transmission, like with a clutch. It's easier to drive. You can teach your wife or girlfriend or son or daughter to drive it. It's not that scary.
Yeah,
But
I definitely agree. So my dad, he had a NV 4500 in his truck, and he got tired of it.
And that's a 5-speed manual transmission.
Yep, 5-speed. So it was a 1998 5-speed manual, and he got tired of the clutch, and he heard about all this power that you can hold with autos, and so he got himself a 47 RH, so he wouldn't have to shift it. And then I gave him one ride in my truck, and he's like, "Can I do this to mine? I want a full manual." So yeah, now my 63-year-old dad is going around slapping gears with the best of them. So if he can figure it out, anyone can figure it out. And it's really nice because a 4-speed transmission, you have 4 speeds to choose from. It's kind of limiting, and so at least I want to be able to pick which speed I'm in. Like, because then if you get 4 speeds and you can't even choose which one you're in, a lot of times it's in the wrong one, and it's not great to hot rod because you can't like spool the chargers like you want, and it's not really that great for towing because you can't have that full control that you really want when you're towing. And so having a full manual valve body is really nice. It's really fun.
So back on the 47 RH, they have this hydraulic governor in there. They have a longer tail housing on the 4-wheel drive. The 2-wheel drive is the same length on all 3 models, but the 4-wheel drive 47 RH is longer. So they kind of have a special, they have a little different output shaft. Internally, they're the same. They have 4 clutches in 3rd gear, same as a 47 RE. The forward clutches, I mean, they're different thicknesses and stuff, but they're the same essential clutches and lining. There's not really an advantage. The only real advantage I'd say in a 47 RH, only in the 4-wheel drive platform, is it has the strongest output shaft of the 4-wheel drives. It doesn't really need a billet output shaft till you get, well to the 800 horsepower plus range. But other than that, it's no real different. You get into tell us about the 47 REs.
So the 47 RE, they took that same hydraulic governor on the back, and instead of controlling it with that governor on the output shaft, they're now controlling it electronically. And so the computer ramps up your governor pressure to like replicate what the output shaft would be doing. And that's how it gets those gears to happen.
That's why they call it RE, because it's electronic now.
So 47 RE stands for 4-speed, 7 on the torque scale, and rear wheel drive electronic. The RH is rear wheel drive hydraulic. And then you get 48, 8 on the torque scale. Apparently it's a little stronger. But yeah, so in the 47 RE versus 47 RH, you covered most of it. Now you get a couple aluminum planetaries differences. Some are made out of aluminum versus steel on the RHs, so you get a little weaker factory. But like say, what's nice is you can swap all those upgraded planets into your 47 RH, no problem when you build it. And so,
Did you say they had steel planets in the 47 RH?
They had some steel planets in this 47 RH or RE, and then the 48s they went to all steel planets.
All steel planets.
So the RH has the most aluminum planets, arguably the weakest planets, and below 500 horsepower, it probably doesn't matter. Above 500 horsepower, the 47 RE is a little bit better planets as it starts, and then the 48 RE has the strongest planets in Sunshine.
And they're steel, and they actually have more pinions.
More pinions,
right?
yeah.
Yeah, so it's actually spreads a little more. So that's why you get that higher torque scale. That'll probably a little.
Yep, more clutches, more pressure, more pinions.
But what's funny is so all these were based on that old 727 gasser transmission. I pulled an old one apart out of one of my muscle cars. It has a 3-pinion aluminum planet in it.
Oh my gosh.
And this RH that we're dogging on has a 5-pinion aluminum planet. Like to a gasser guy, he'd be like, oh my gosh, 5-pinion aluminum lightweight. This is a race part from the factory, and we're just like trash, throw it away. I want to steal one. Yeah. So it's all about your perspective and the torque you're trying to put through it that makes a difference.
And then going to your 48 REs, that's when they made the most changes, I would say, internally. They went to a direct drum that now holds an extra clutch. And so that helps.
Instead of 4 clutches, it has 5 clutches, and they're thicker.
A little thicker. They moved the snap ring groove, and so that's nice. And they made some other changes in different parts to accommodate that. Then they went to all steel planets, all steel 6 pinion planetaries. 47s all had like either 4 or 5 pinion planets. Some were aluminum, some weren't. 48s have all 6 pinion planetaries. The sun shell is a little thicker on them where it engages the direct drum. They can get to where they start to wear a little bit and starts to clunk around a little bit.
You get like 300,000 miles and the sun shell wears on the 3rd gear drum. There's some tangs that interlock there.
Mm-hmm.
And the 48, they fattened that up.
Yep.
Probably
A good amount.
Because they know that it was a wear item behind a torquey diesel.
Yep. And then aside from that, the overdrive housing's like the exact same. They made some changes into like just the design of it a little bit with the parking prawl, but otherwise it's the same exact horsepower for horsepower. It'll do the exact same, other than it has the 6 pinion rear planet in there as well. And then another change they made
for the overdrive planet.
Yep. And then the pump flows a little bit more. So that's like when you start talking about higher pressure, you have more leakage and stuff in the valve body, in the transmission, and all your extra fluid is what's going off to go charge the cooler. And so you bump up the pressure a little bit. There'd normally be a little less pressure going to the valve body, or a little less pressure. There would normally be a little less flow going to the cooler circuit. So they bump that pump flow up a little bit.
So what do you do in these transmissions? Like, I mean, I know we have a bunch of different power levels, like 650 is kind of our most popular one.
Mm-hmm.
Why is that our most popular transmission? Is it the best? Like, I mean, what do we love about that 650 horse transmission?
It's very well rounded.
That kind of does everything well. I mean, you actually drag race with that on accident.
So last year, right before we went to Montana to race, I had the Junker drag truck that had a 650 towing transmission in it because we were using it for some turbo testing. And yeah, we just made it used to be very violent. Like it'd spin the tires on the dyno when you shift gears is so violent. So
and like I built that truck and like the valve body to be a good truck for like employees to go drag race. It's not going to break loose on the shift. I try to make it super squishy. That way there's nothing like you got a first time, second time drag racer. You know, first of all, 600-700 horsepower is just fine for them. Secondly, like you don't want it to be harsh or weird or like jump or spin on the shift or whatever else. And so I built it very soft. I built it like basically one of our towing transmissions. Like that's what it was. And then we get Will Terry in the driver's seat.
So I took it up there racing and it was making what, 980 to the tire?
960, 980.
960 to 980. I mean, upper 900s to the tire. I was running a 660 or a 670 index and actually got it to run a 660 something. So we're talking deep 10-second quarter mile times on this towing transmission. And I was like, man, this thing would be so much faster if these dang shifts would grab faster. But what I'm getting at is that 650 trans will hold a lot of power short term. The main reason it's so popular, it has that billet input shaft. It seems like around 500 horsepower, the stock input shaft breaks. Because the torque converter won't hold 500 horsepower greater than about 850 foot-pounds. You put a triple disc torque converter. If you take a stock transmission and you put a good torque converter in there, the input shaft breaks because now the converter doesn't slip, input shaft breaks. So the 650 has that billet input, a good triple disc, a good flex plate. They've addressed all those weak points. Then we've upgraded the clutches. And the other big thing is you get all of these lubrication mods. When we try to build a transmission to hold like 2,000 horsepower, we learn a lot about spraying oil on clutches to make them live. I mean, when you're trying to grab overdrive on a 2,000 horsepower plus truck to the tire
at like 5,500 RPM.
And it's got to suck back 1,500, 2,000 RPM of engine momentum plus the power it's making. Those clutches get hot. So we've added lube mods everywhere. And we spray oil on the overdrive clutches. I don't know very few builders in our industry that spray oil on the overdrive clutches. Well, guess what? If we do that same mod on a 650 towing transmission, that dang thing, those clutches are going to look brand new after 500,000 miles. I mean, we made these things as bulletproof as possible. Now, if you don't do maintenance and the filter gets plugged or you hot rod it and the input shaft breaks, all these things could happen. But you know what? Those dang overdrive clutches are going to look spotless. And so that's what's so good about the 650 is we're adding oil there. We're adding oil in the 3rd gear clutches. on all these factory transmissions, if they've been around a long time, they always have hot spots on the third gear or the direct clutch linings. The steels get little hot spots because they kind of drag a little. They have a lot of heat. But we've added a lube mod to the input shaft that forces oil into that third gear clutch. And now, no more hot spots. If there's hot spots, all of them have hot spots. In the past, there's only like the top, 1 or 2 steels where all the heat was. The whole pack wasn't having an even amount of heat. That's another thing that 650, lube mods there. The overdrive piston support. So there's a middle, the main intermediate shaft that runs through the transmission that all the planetaries spin on. It lubricates. Well, it doesn't lubricate well where it goes through the overdrive piston support. So we've added some lubrication mods there to get more oil on that shaft. I had never had a problem with that up to 1,000 horsepower in my junker. Along comes Todd with his 4-wheel drive Frankenstein truck that's making, what was making 1,300 horsepower at the time.
Yeah, probably.
And it's twisting and binding the case and the shaft so much. I mean, he's friction welding the intermediate shaft to that overdrive piston support. And guess what? I learned about lubrication mods there too. Well, I didn't learn about it. We developed it to fix a problem. So that's why that 650 is so popular, because it has a good converter, has a good input shaft, has a lube mods, has a good clutch linings. We've learned from racing these GPZ clutch linings, they can slip without getting torn up and glazed. They're very
forgiving.
A red Alto full race clutch, I think it has a little higher coefficient of friction. It'll hold a slight bit more torque until it slips, and then it holds way less. These GPZ linings we're putting in there, huge deal. The way we've set up the shift timing, the trade-off from second to third gear to make that second gear band last, you can't bind up the 2-3 shift on a 2,000 horsepower truck. Second gear will not hold up. So that's better. We do a 4.2 ratio lever. We change the leverage on the second gear band to make it apply better. We've got special servo covers so that we've eliminating leakage to, eliminate bind up.
We can really go through and do a lot of the 650 build is built enough that we can go through and take care of a lot of basically all of the little gremlins that are left in the transmission. What's also really nice about the 650 is it's the highest horsepower level that I would recommend putting in basically any stock truck. You start talking about people want to put 1,000 horse transmission in their stock truck. That way, oh my gosh, I'll never have problems. This thing's overbuilt. Well, the problem with that 1,000 horse trans, it comes with 1,000 horse pressures. And you start running that kind of pressure on the absolute daily, going up every single grade for minutes at a time, it's just going to run a lot hotter than it needs to.
So stock's 100, 120. Where's 1,000 horse trans pressure from us?
1,000, you're right there at 200. I mean, that's a lot of pressure to be just sitting there cruising up a grade. The transmission it was designed for half of that. And so what's nice about 650 is it comes with about 160 PSI line pressure. That's perfect. You can pull grades all day with that. I mean, you definitely need good transmission coolers, which whether it's just healthy stock ones or additional ones, just keep that transmission temp cool. That's all you need. And you can run that on basically any truck you want. And billet input shaft, just all the gremlins taken care of. That's why it's such a popular transmission, is because it's stout. We fix all the gremlins, and you can put it on any power level, really.
No, I mean, you used to get on this a lot with people towing. If you have a lower powered truck with that high powered transmission, they're using a lot of throttle input to pull the hills.
I've explained this to a lot of people. Basically, if you take a stock truck and you are towing with it, you're floored. I remember towing with a stock truck. I was floored every single grade. I was taking runs at hills to try to get up the hill. And that's the way it rode. And when you're pulling that grade, you're at 100, 120 PSI, whatever it is. Perfect. When you put a 1,000 horse transmission in your truck, your stock truck, now you're going to be pulling those grades at 200 PSI. That's a lot of heat. That's a lot of pressure. Well, if you put that 1,000 horsepower transmission into a 1,000 horsepower truck, you're not flooring it to get up the grades anymore. You're sitting right, call it 30 PSI, 30% throttle. And guess what? 30% throttle, that puts you 140 PSI. Perfect. You're right there in the range again. And that's where it's really important to match and be realistic with what you're doing and match your transmission, or especially your valve body, to your actual truck.
Because I mean, the same is true if you put a stock plus transmission that's making just a little bit more than stock pressure in a 1,000 horse truck. You're pulling the grade at 20 or 30% throttle, so it's only making 80 PSI line pressure, and that stock plus tranny is not going to hold because you are not giving the transmission enough throttle input to make the line pressure you need.
And that brings up another point too, is that like we're only just talking about the peak pressure. Like what does it make when you floor it in a lockup and overdrive? Another thing that we do is we make that curve different. We get that pressure up sooner. And so the factory doesn't make full pressure until full throttle. Now we're getting that meat of the curve up higher in the medium throttle. That way you're not waiting till full throttle to actually get that full pressure. And that really helps. I mean, these diesels make so much torque. I mean, you guys are familiar. You can give it half throttle at 1500 RPM, and that's a lot of torque. Well, your transmission wouldn't be at full pressure. And so we do some stuff there to try to get that pressure to come in sooner to help take care of those situations.
What about like as we go bigger? Like I know, I've all my trucks have the fat input shaft. So you said a billet input shaft, but there's even more upgrades beyond that. There's fat inputs. There's a lot of technology in converters. Like now let's start talking about some, the fun stuff we like to talk about, like big converters, high stall. There's a whole nother, like we've talked a lot about the street guys, but there's a whole nother world for race stuff. Like you start going big, like I know line pressures, but difference in converters, stall speeds, shafts. Like let's talk about some of these things.
I feel like that's where Will Terry's going to shine right now.
So the first shaft that we like to, we call a magnum or a fat shaft. So factory transmission has a 23 spline input shaft. The fat shaft or the magnum shaft was a 27 spline input. The more splines, the fatter the shaft. It's about 100 thousandths bigger in diameter. It came from the 68 RFE platform. So you added the bigger shaft with the good 300M alloy, and now you have a shaft that'll hold a tremendous amount of power. 1,000 horsepower, no problem. I guess we put all the way to 2,800 through the Godfather.
Yep, that's a shaft that I had in it on that dyno run.
Short term, we never broke one in that truck, but I don't suspect it would handle that power level for years and years of racing. That's
it's pretty wild. It's pretty wild.
A usable item. But so in the world, these bigger shafts, there's that. The factory intermediate shafts, they seem good up to about 850 horsepower. Usually around 1,000, they start having issues. So when you get to about 1,000 horsepower build from us, you get a billet intermediate shaft. The main difference there is you're changing the alloy to a 300M alloy. There's also a miraging if you want a little bit, there's a couple options there as you get higher levels, but regular 300M is fine. They've changed the radiuses. They've changed some of the fluid lubrication holes. They've moved them to make the shaft stronger. There's been some design increases. They've added some fillets and some different angles to just help the shaft be a little bit better. The big thing that happens, though, the reason our 650 is only rated where it is, it has a stock output shaft. You put more than 650 horse through the factory output shaft on a four-wheel drive, and they don't last long. Sometimes they'll last 2 or 3 boost and launches, and sometimes they'll last 5 years towing your horses, but you get really leaning on it, that output shaft's the problem. Mm-hmm. So within that, there's 2 sizes. There's a standard.
It's basically a factory replacement. So it's it's also a 23 spline, right? But it's the same size as your factory one, but it's billet, and they added some material to it in different spots. And so it's
getting a big radius.
Yep.
And like those TCS ones, there's a couple manufacturers, Sonics makes them, but yeah, the billet ones, they're good up to about 1,000, usually about 1,000 guys start going to a fat output shaft.
Mm-hmm. And so that is the output shaft from a manual trans. That's a 29 spline output that would be you'd find in a manual transmission. And so when you do that, you need to swap in a manual transfer case input shaft that's been shortened. And that's how you make that whole setup work.
What about the junker? You're racing right around 1,000 horsepower and it was fine. Why did that not break?
So part of that is the weight and being two-wheel drive. If it had a big torque hit, it would spin. I still broke a couple standard billet input shafts before I had to go to a fat one. I never broke an intermediate shaft on that. Output shaft, that was after I broke the Dana 70 rear end twice, but I broke the output shaft and that cracked because it was an RH and had those governor holes, and it had a spiral crack from that, and it looked like a peeled banana. It wrapped clear around the shaft, like 4 inches of cracks before it finally failed. But the advantage of that, those two-wheel drives are so long, they're like a big shock absorber. So you put a big shock load through that two-wheel drive shaft, it just kind of sucks it up. Eventually, I had to do a billet two-wheel drive shaft, which, to my knowledge now, nobody makes a full-length one anymore. We used to get those from TCS in Arizona.
They're expensive. They're big.
They got bought out by Safety Clean and they quit making shafts. They're now the machine shop for Safety Clean cleaning equipment. And so now you're kind of left with Suncoast makes a stubby where they kind of modify a 4-wheel drive output. They make a longer one and make a Mark Williams Turbo 400 roller output shaft. Anyway, it's kind of a little elaborate thing, but that seems to be what most 2-wheel drives go with now if they're in that 1,000 horsepower. But if you don't have traction, I mean, we've had a few customers break standard outputs on their 2-wheel drives, but you usually get around 1,000 and you just can't hook it up unless you back half the truck.
Really, you have to have a slick and you have to bounce at the track. You do that, that's how you're going to break parts. You can put a lot of power through a stock output shaft.
I mean,
the 2-wheel drive.
I mean, the junker is back to a stock output shaft now in that 650 trans. And I have a video of it pulling wheels at the drag strip. I mean, around like a 150, 60 foot.
Yeah.
I don't know how long it'll hang in there, but you know what? It did it a couple times.
That's what matters.
On the towing valve body. That's awesome. What about like converters and stuff? And they got the big out. You got the big input shaft. Well, did we talk about the 35 spline? Did you get that
No,
one
we
yet?
didn't.
Now they have a new one on top of the 29.
So the new kid on the block, Sonics, made a 35 spline input, and they truly made it fatter everywhere, clear through. Most of these other fat input shafts, they still had the same major diameter right where they met the hub, and Sonics fixed that with these 35 spline inputs. I have one in my race truck now. I was running a Magnum shaft before. I had never hurt the shaft. I simply went to the 35 so that we could stay with R&D because I can't buy those Magnum shafts anymore. And so I was like, I got to have something to sell customers. So I better test this out on my truck. So I have a 35 spline now. It's even bigger, even fatter. It's about I think a old Magnum shaft is like a inch 110 thousandths or something. Those Magnums are like an inch 250 or an inch 275. They're,
I've never measured, but yeah, they're chunky for sure.
And so that seems to be what all of the fastest race trucks that are running 48s are running. We haven't really talked about torque converters yet.
Yeah, there's a ton of thought, information, and how your truck responds if you put the right torque converter in the dang thing. If you have the wrong converter in a big turbo, your truck's going to suck. And if you have a really loose converter with a small turbo, it's also going to suck.
Yeah.
You got to match that converter to that turbo. And I learned a lot years ago. I got my very first hot rod transmission automatic. I swapped my truck from a manual to transmission to an automatic, and I had an Aurora 5000, which is that the old ATS turbo. It's a
K31, right?
K31, like a 70 millimeter charger, and it was my first experience with an automatic and a diesel, and the converter was so loose, it was awful driving anytime it wasn't locked up. Once I got the lockup, I was like, oh, this is super fun. But everywhere unlocked was just like, I understood the term slush box really, really well because of that. I mean, I know that's not what they call it that, but it just felt like I was slipping all the time because there's such poor power through the converter until it was locked up. So getting your converters right is great. And also, if I had that same converter on like a small turbo, I would have been like, turbo is done before, like, it just wouldn't have worked. Been awful. So yeah, I'm a big fan of the right converters. What do you think?
So, I mean, in drag racing, you're trying to make the converter loose enough that you can, build enough RPM against the brakes that you can get the turbo to spool up. And your stall speed is directly related to the torque. So if your vehicle only makes, let's say 200 foot-pounds of torque before it has boost in there, any converter is going to act kind of tight on it. After it makes, let's say, a couple pounds of boost, now it's making 300 foot-pounds of torque, and now the RPM goes higher. And it just continues to stall higher and higher as you make more and more torque. So getting that dialed in is very important. Back to like a towing application, most towing torque converters that people order and people prefer are actually lower or tighter. They couple better than the factory torque converter. The only people I hear that complain about that, they tone their trailer up to Brian Head at 10,000 feet and they try to back up with their 35-inch lift kit tires. And they can't even build enough boost to back up their fifth wheel toy hauler at 10,000 feet. And they have to use low range, and it frustrates them. But that's because the converter is so tight, they can't get any boost going, and they don't have enough gearing with the big tires and stuff. So the only place it really affects you when it's too tight is when you're first pulling away from a stoplight, the amount of heat it builds when you're sitting at a stoplight. A tight converter pushes harder against the brakes and stuff. But once you're moving, that tight converter feels good because it couples and it like holds the engine. If you've, let's say, doubled the torque on your engine, the factory torque converter is way too loose because the RPM is going to scream with that higher torque load.
That was really apparent to me my first go around with Ruby and a torque converter, because I had it. It's a good torque converter. This is now, I'm now at 1100 horsepower. But
Ruby, you're talking your 06 mega cab.
Yeah, now when I'm towing, I'm not towing at 1100 horsepower. I'm towing probably maybe 700 or 800 horsepower. But the converter was, when I was emptying the truck, it felt fine. Driving around, no big deal, good power transfer. But I always hated hooking my trailer up to it because, again, like my old, first time that automatic transmission, when it was not locked up, I could just push through it like zing right through the RPM range. It was awful. I didn't have hardly any power transfer, I felt. And until I had lock up, then it was great. And so we got a different converter in that. We got one of our power torque converters that we kind of had it made just for the right stall speed. And then it was great. So now I can like pull my trailer nice and makes good power, and it works great. And then even until I hit lockup, it feels really good. So I don't think it's lower stall. I think it's just coupled better than the one I had before.
There's a lot of black magic voodoo in there, and the blade counts and the pitch and the stator. There's kind of three components. There's kind of like a pump that's the part that's hooked up to the transmission. There's the stator in the middle, and then the turbine is the side that all the oil's pushing on in the front half of the torque converter that is splined into the input shaft. So all the power comes through. So you have three sets of blades there that can manipulate fluid, and couple, and there's one-way clutch or sprag on that stator. I mean, there's all kinds of little things that companies do, clearances and stuff there that affect the way things couple. And it's interesting looking inside them, but it's definitely like an art to itself.
I remember years ago, you wanted to understand torque converters. It was like your mission in life to figure out how they worked and all the pressures and stuff. And you like build a custom case or something to figure out how the converter works. And you're actually talking with like some pretty big names in the diesel industry. They're very curious about what you were doing, like trying to, because you're getting data that not even they had. And so you really figured out a lot of the stuff on that.
So what happened is we had this Godfather race truck, and it would burn up the lockup clutches in the torque converter without commanding lockup, just by sitting there building boost against the torque converter. So Todd would do a practice launch, build boost, and by the second one, the filter would be plugged. There was so much debris from the lockup clutches dragging. And what we found out was, so the way the lockup clutch, there's a clutch pack inside the torque converter, or a stack of clutches. In this case, there was, 3 friction discs in there. Well, 2 friction discs, 3 sides that were active. Anyway, these friction discs are in there, and as the way the input shaft works is it's hollow, and oil comes through the middle of the input shaft. It goes into the front billet part of the torque converter, and it floats the lockup clutches off, goes around them so that they don't drag, and then it goes back into the fan blade section and makes all that fluid for coupling. Then it goes out of the torque converter, out through the valve body, through the cooler, lubrication circuit. When it's in lockup, it goes the opposite direction. Instead of it sending fluid through the input shaft, it now sends fluid on the outside of the input shaft through those fan blade sections, pushes that lockup. There's a piston in there down, applies those clutches, and then the oil that's trapped under those clutches comes back through the inside of the input shaft through a switched valve in the valve body, and it vents. So any oil that leaks past them vents out. What we found out is when we got over about 100 PSI of release pressure coming through the input shaft when we're not in lockup, the oil could not come out of the torque converter fast enough. And it was making an apply pressure build up without us commanding apply on the backside, and it was making those clutches drag. Now, if you're in a stock torque converter and you're building boost, 20 pounds of boost, and it's at, 1800 RPM, 1800 RPM of the clutches are spinning and the input shaft is stationary because you're not moving, that's 1800 RPM. On his truck, when you're at 4000 RPM, a lot more surface speed there, and when you're putting way more pressure in there, it was making these linings burn up. And so, but you couldn't give us information. How did I measure these pressures? I had to drill and add ports and holes and copper lines epoxying things into the case, tapping into the pump. Had all kinds of gauges instrumented. And we did this on the junker drag truck because, Todd's big race truck, it was hard to like sit there spooled up for 3 seconds and look at everything.
Yeah, starting the smaller, yeah.
But we learned a lot. And that's kind of where we came up with on the race trucks, we have a dump valve. We're actually figured out a way to vent that buildup pressure out of the torque converter. And so it dumps that excess fluid off and it makes the torque converter stall higher, which helps for spool up.
Yeah,
and it keeps those clutches
easier to spool up with that on. Yeah.
But you can't do a dump valve like a traditional gasser because they don't have a lockup clutch. And so when they do dump valve, they just cut off the feed of oil to the torque converter. Remember how we talked earlier about that converter drain back and how it feels like your transmission slipping when you first start? That's kind of what a dump valve does on a gasser like Turbo 400 race transmission or a Power Glide, is they're dumping that feed oil that's supposed to go into the torque converter, making the oil in those fan blades cavitate so they don't couple as well, and it raises the stall speed. And then they close that dump valve after the green light drops and they start running down the track. You can't do that on a diesel or 47, 48RE because that oil is what releases the lockup clutches. So if you dump off the oil that's being fed in there, it's going to burn up that clutch even faster. So it's kind of an inverse dump valve that we had to do. We had to figure out a way to dump the pressure that was building up on the lockup side of the system. But you have to be able to close that because you need a tight seal when you command lockup. Otherwise, it'll blow it out the dump valve. So it's kind of technical and ornate in there. But when you learn things about that, you get a lot better at building like towing transmissions. Like, for example, on this big power truck, we couldn't keep a set of thrust washers alive in the planetary set. Todd would do one sled pull, and all the thrust washers would be wiped out in all those 48 planets, and all that metal would be in the filter and in the pan and plugging things. And so what did we figure out? Well, we need to put Torrington bearings in all of that gear train, all those planetary assemblies. Well, guess what? After we figured out how to machine it efficiently and make it affordable for us to do that very expensive operation, guess what? Torrington bearings last a heck of a lot longer than thrust washers, even on your 650 horse towing transmission.
So they're in there.
Yeah. Keeps the metal out of the pan. I would hate when I'd get a potential warranty call. He's like, hey, I did my first service and there's a couple brass shavings in here. What do you think it's from? And I'm like, thrust washers. You're like, how do I know it's from the thrust washers? I'm like, well, there's nothing else really brass in there. But, well, guess what? After we put Torrington bearings, we never get a call about brass shavings because they don't make them anymore.
Yeah. So that's actually been a big benefit here. Now that's kind of like a separator here from the DIY guys versus what we build here, because the DIY kits, it's kind of something that's hard to actually do. We can machine it, but the assembly requires special stuff. And Myer can talk about that a little bit, but why our DIY kits do not have that, but our built in-house transmissions all do.
Well, I mean, in order to machine the parts, we have to have the parts. And that's a lot of it. And then we set them up when we set up those clearances in the planetary with the thrust washer. With the Torrington bearings. We take the stock clearances that say in the book for thrust washers and we throw them out the window. We do basically set them up all differently. And we want to make sure that you still, not only do you have the right clearance in that assembly, but you also have good clutch engagement on on the forward clutch and where the low reverse drum goes into the rear planet. So that's really most of it. Mostly being the fact that we have to have the parts in order to machine them. So it makes it hard when you are sitting when the parts are sitting in your garage.
Can't machine them over there. Gotcha. Makes sense. Well, anyway, that has helped a lot. Like you said, with a lot of the warranty claims, it's pretty much gone away, and it's been very, very helpful.
Yeah, Torrington bearings are nice. We've never had one fail. They've been awesome.
Yeah.
I mean, they're in an oil bath. There's forced lubrication all around there. I mean, they probably have the best. I mean, it's designed for a sliding brass washer to live. So surely some roller bearings with all that extra oil there.
Gonna do all right.
They're safe.
Yeah. So I know, like, out there floating around in the high level stuff, there's like SFI cases. They're kind of still somewhat new.
Mm-hmm.
With that dump valve, like, you spend a lot of time working with the manufacturer of that particular case, and now all that routing we did in epoxy and copper tubing
is now cast into a case. It's pretty cool.
Yeah. And that was you working with the actual casting.
I gotta say, is also Will.
You and Will.
Largely Will.
So, because we got contacted by this manufacturer about this case, and we're like, dude, if you're going to do this, you got to put this in here because any real big power drag truck needs this. Like my case has it, yours has it. Like we got a couple test units here, but that like is like so nice.
And some of the builders that have used these SFI cases, they don't even know what those ports are for. They're like, oh, more pressure ports you can read. They have no clue why they're there.
Yeah.
They're like, why is this so big for a test port? I'm like, because you need some volume to make the dump valve work. It doesn't, by the way, it doesn't work with 1/4 inch or 1/8 inch line. It needs more.
Yeah. You got to put some big stuff in there because that fluid needs to move. And so anyway, probably people have that don't even know what this is for.
It's like, what are these random ports here? And they're kind of annoying. They're kind of close to some of the other stuff on the, for some people, but there's only so much real estate on the transmission. But the big thing on the SFI case is because it's rated for like a planetary explosion tested to 10,000 RPM, you now don't have to run a transmission blanket with it, which is a pain. Because transmission blankets do not fit diesel transmissions very well.
Oh, they're terrible. I hate them.
They don't fit around deep pans very well. I mean, it's just a pain. The bell housing, it was hard to get a bell housing that that was rated for that SFI rating. It was just a nightmare. So
yeah, those cases are still kind of hard. They're not like everywhere. And we're hoping in the near future they're more readily available. But it's still kind of like in the early stages of that particular thing, as far as I know. You guys probably know more than me.
I know
they're still working on them.
I mean, a lot of the top racers have given up on the 48s and they've gone to these lockup turbo 400s. And those are a great unit. Those Rossler units, were they $25,000?
It should be great.
Yeah, I hope so.
But at the same time, I feel like some of their innovation stopped when they kind of abandoned that. And I feel like we've kind of kept the 48 innovation going. I mean, there's still things like Myer's got a new lube mod right now to make second gear band last longer. I mean, I don't know anybody else doing that. Why are we doing that? Because
when it breaks, you got to figure out how to fix it.
Yeah.
So, I mean,
we're sticking with the Dodge 4-speed, so we can, all of our race trucks have 48s or modified 47s that are basically like a 48 with that steel guts and stuff.
I mean, maybe someday Todd will have a dragster with a 48 in there. Wouldn't that be cool?
They used to have them back in the past. Nobody runs them now, I'm sure.
I think even Michael went to Turbo 400 now, isn't he?
I believe so. I mean
he's
a great drag race.
He's the fastest guy out there. So, I mean, whatever he's doing is working.
Yeah, there's a reason they've gone to it. I can't say they're wrong. If they want to go faster, this is an easier way to get there, for sure. Mm-hmm. And so, but I mean, for us, we want to know what we can do with the Dodge. We want to, keep moving with that transmission. So
we didn't really talk about line pressure. That's another like hot topic that all like at this competition level.
Yeah, how high can you actually go?
I remember back in the day, like, guys, you don't need more than 180 PSI. That's all you ever need. Mm-hmm. Big names in the industry were pushing that fallacy. Yeah. And I mean, what have we seen, Myer?
I'm going to say I disagree. Yeah, I mean, we were getting ready for UCC 2021. The last UCC we went to, the one that it blew up, on our dyno, we had everything working. And I remember I feel like it was like, I want to say cloud 9, but that truck always broke. Every time we dynoed, it was like a shock if it was ready to dyno again. Like it was always breaking something. And we had it, and we dynoed it, and it was great. And it made 2,800 horse. And we're like, dude, we've got a recipe here. Like you had done a bunch of head porting. We had the cam. Like we had all this stuff in there and it just was working. We got the straight cut gears. And that was huge. And it didn't break. And it made 2,800, and we were thrilled. And then we went back, and it was ready to dyno again. So we let it cool down, did another dyno, 2,400. We're like, what? And so then I think we hooked up some more pressure sensors to see what was going on, did another run, 2,400. And we were like, oh, the dyno rollers are slipping, whatever. We did another run, I think. And we said, no, they're not slipping. We looked at data logs and stuff. We were data logging, and it's just like the best we could figure, the transmission was slipping. And so we looked, and the line pressure I'm not going to say what it was, but it dropped down to 240. And we're like, well, I guess that could be it. So we tried playing with the lever. It wouldn't go up. So we had to pull the valve body back out. Turns out in there's a lot of stuff going on in that valve body. And one of the orifices that we used to increase pressure got plugged. And so we had to go through, clean it all out, put in the test stand. Yep, we're back to full pressure again. Put it back in the truck, and went right back to 2,800. Like I don't know what more testament you want that you need pressure.
But in short, 240 was not enough to make the whole 2,800 hookup to the roller.
I want to say, like, there's a lot of people that have made power on dynos, especially big power. I mean, lots of people have been or a good number of people have been at 3,000 horse. I would say that what we were doing was a little different than that, because all these people now are just spraying nitrous at it. And so that run is a 3/4 of a second run, half a second run. Like Greg A is doing it and he's making good power. You can hear him. He is making good solid power. But like the Godfather, try to spool 3 GT55s, ultimately fuel only on a 12 valve. That is a long pull. So things that they are getting away with, we could not get away with. Like, I mean, I remember one time we tested out a new converter for a company and one pull just absolutely, I mean, had the paint peeling off that converter. Like not a little slippage, a lot of slippage, because
this company's like, we build the best converters in the world. And it's just like, oh, really?
Yeah, I have a lot of I don't want to say the color of the paint. I have a lot of paint on the ground that would argue with that. It was like sheets. It was impressive.
Yeah, a lot of heat.
But where we kind of first started playing with it, I remember the junker, when I started getting the pressure higher, would go faster. And in my case, I felt like it was because the shift, the impulse time was shorter. It would shorten up the shift window with more pressure, and it just would pick up ET at the track. And so I felt like, yeah, you don't want to shock this violent shift for, hauling horses over the mountain. But if you're trying to hold big power and go fast, you need line pressure. The danger is you get up there, north of 200 PSI, and sometimes the converter starts ballooning.
Yeah.
And it drags and it pushes on the thrust on the engine. You wipe out the main thrust in the engine because the torque converter ballooned, and pushes on the transmission pump as it's thrusting. And so it wipes out the transmission pump. I mean, there's a lot of stuff that goes bad when you start getting mega pressure in there. I mean, you do a high ratio lever and a billet, the right billet servo, you'll break the case in second gear with, big pressure. So, but there's a lot of people I've seen on the dyno, people that, like you said, they're competitors of ours, basically, as far as transmission builders and I've talked to them and they think I'm nuts. And I just want to see them succeed. I don't really care who makes 3,000 or 4,000 horsepower in the dyno. I think it's awesome. I want to see everybody do it. And a lot of these builders are running too low of pressure at that level.
And like, I feel like this is something that we get caught up in sometimes, but like being data junkies. I mean, a lot of people will say, oh, I looked at the data logs, like it's not slipping or this or that. And we do the same thing with the dyno. Like, oh, we picked up 10 horsepower on the dyno. We're making more power. So it should go faster on the drag strip. You know how you know if you're going to go faster on the drag strip? Is if you go down the drag strip. If you bump up the line pressure and you make more horsepower on the dyno, I don't care what your data log said, like you must have been slipping before. And so that's just the way to actually for sure know. And that's how like a lot of our experience comes from trying to make stupid 12 valves make power. You got to figure when it's so hard to make power, you got to figure out how not to lose it.
Yeah, it's very fun over the years. The things we try to figure out, things we've worked with. And, yeah. Late nights, many late nights. But yeah, line pressure is a big deal. Like you say, people made power with less. But, I mean, are they leaving stuff on the table? And surely they are. Some people say, well, it's a choice because of reliability. If I go this high pressure, like Will said, all these potential downfalls are a real problem. Maybe I give up 100 horsepower or a couple hundred horsepower in my case, but
and
I can make it through an event. That's a good thing.
And I'm definitely not recommending that every street truck out there start running 200
or any
20. Start running over 200 psi. I would say 200, 210. That's fairly safe for a stock transmit or a street built transmission. You start getting over that, you start running into a lot of little gremlins of where that pressure is actually causing problems. Your billet Belleville springs aren't strong enough. Your input shaft starts getting pulled through the input retainer. You got converter issues, which a lot of people are very familiar. There's just like all sorts of little gremlins you have to go in and to address it into like that level of a build. But I think for most like 1,000 horsepower people, like 200 is not something you should be afraid of.
And it's not that 180 or 185 doesn't work. It slips a little. It cushions the shift. It saves hard parts. It saves traction. And maybe if you have a 4,000 pound race car or really lightweight truck, you can kind of get away with it. But I promise you'll go faster if you put more pressure in there. And, if you're breaking hard parts, well, that's another thing. But
you need better hard parts.
That's right. Mm-hmm. Well, Yeah, you got any other cool things to think about, like race trans or something would be helpful to people?
So I actually want to circle back because that's something I was thinking about just a bit ago. Will was ranting. I was definitely paying attention. The 4748s get a really bad name, factory. Like they're Dodge Automatics. They're terrible. They're slush boxes, whatever. One thing that they have going against them is that they are the only diesel platform that doesn't defuel for the shifts. Like Allison's defuel for the shift, 5Rs, they defuel for the shifts. So factory, I mean, if they're rated for 300 horse, they bump it down to 150, it shifts, it goes back up. Dodge autos don't do that.
So basically torque management happens on every GM and Ford and now Dodge transmission.
Mm-hmm.
But the reason these 47 and 48s got a bad rap is there was no torque management. So they're strapped behind the most powerful as far as torque diesel out of the three platforms, and they didn't do torque management. No wonder the 47, 48 got a bad name. I promise you, if they took the same shift strategy behind that comes behind a 6-liter Power Stroke, you do the 48. Whoa, what was that?
Got a little thing going on over here.
That was like an idea ball just popped up. It's just like, put a 48 behind a 6-liter, Will. It'll go fast.
Yeah.
They will survive. So yeah, torque management's huge, and they didn't have it all
Which
the way
is
up
one of the
through
reasons it's actually probably the preferred race transmission, because it's not smart. It just
That
goes.
is very true. You get a dumb transmission, you can outdumb it. It works really well.
Yeah, and that's why a lot of people put those in behind Duramaxes and others, and probably some Fords too, because it just kind of does what you tell it to do.
Yep.
So one final area I think that we didn't really cover is there are DIY guys out there. And as far as a DIY transmission, 4748 is fairly easy to build as far as stacking the parts in the right manuals.
Yeah, there's like very little specialty tools you need to do them, and they're quite simple. Yeah, the valve body I would say is the one thing. Like it's one of the more complex valve bodies. You got a lot going on there. There's so many circuits left over from the 727 days that are active enough to screw you if you do it wrong, and that's it.
And most of the shift kits on the market they just have a lot lacking. Like you put a Transgo shift kit, it's a fine shift kit, but what does it make? 140 psi on 47,
and you can bump it up, and it has like gremlins in there. The shift kit itself causes some problems. We use the base parts, but we definitely build them a little different.
48, it's not as hard to get the pressure there, but you can also get too much pressure very easily. But yeah, as far as the DIY build, they're not that bad.
No.
Parts wise, they start with there. You start putting billet, exotic heat treated alloy parts and things. They get expensive, but compared to a 68 RFE, 48 is affordable.
Oh yeah, for sure. I mean, you can get yourself like a 650 kit, very reasonably priced. Anyone that's wondering if you should build your own transmission, I will basically always tell you, absolutely. If you think it's something that you can handle, 100% go for it. Try to build your own transmission. Get yourself a good kit. Bonus points if you get it from someone that's willing to help support and answer questions that you ask. And if you have any kind of hesitation, buy yourself a valve body. That way it's been built, it's been dyno tested, it's good, and then build yourself a transmission. And it's a great way of saving some money without really lacking on anything. Like it'll be a good unit when you're done.
As far as like the lubrication mods, they really do help. If somebody would like to see a video on like how to build a high-end 47 or 48, DIY, I mean, you got to blow up our comments. We need a lot of people telling us, hey, I need to see this. I need to see these lube mods. I need to learn the tricks of the trade. And, if enough people ask, I'm sure we can figure out a way to get our camera guy to film Myer or myself building a 47 or 48 and making it awesome.
Yeah, because it sure won't be me making it.
We can walk you how to do it. If Todd can do it, anyone can do it.
That's right.
We need a lot of comments on this, all right?
Yeah, for that one.
Todd's like, you're going to teach all our competition how to build transmission, you idiot.
Yeah, there's a lot of good competition. It's out there well known enough now. It doesn't really matter. But anyway, so.
Not all of them.
Yeah, that's true. Not all of them.
Been in lots of transmissions.
Yeah, a lot of people just.
We're not going to names drop, but there's very few that do all of the lube mods.
Yeah. So anyway, guys, I think that's going to kind of wrap up this episode for the 4-speed Dodge transmissions, the greatest piece of crap ever made.
That can be built to be the greatest transmission on earth.
Yeah.
On Earth's a big statement.
Yeah,
The
it's pretty-
greatest Dodge diesel
There you go.
Cummins 12-valve transmission.
There it is. They're pretty good. They can be really good. So anyway, I hope you enjoyed this. If you have any questions, call us at the shop. We're happy to answer and help you on your builds. And yeah, that's going to wrap it up here for the Power Driven Podcast. Thanks, guys.